Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. I hope all of you are doing well. And we are very lucky today. We have our guest speaker for our online webinar series. And this is a webinar organized by the Department of Aerospace Engineering in collaboration with the Malaysian Society for Engineering and Technology. So together with us today, we have technologist Dr. Nadiir Bheekhun. He will be talking on the topic of gearing towards quieter skies for sustainability. And Dr. Nadiir himself is our alumni. Right, probably later on he will introduce himself. But before we begin, I would like on behalf of UPM and MySET, we would like to thank Dr. Nadiir for his availability to give or share his knowledge on the topic today. So without further ado, I welcome Dr. Nadiir to give his talk. Thank you very much.
Okay, Assalamualaikum and a very good morning, everyone. Thank you, Professor Abdurrahim, for the brief introduction of myself. So today, I have been given the opportunity to share a bit of knowledge on the sustainability related to quality skies, that is noise reduction and its technologies. I should be thanking also the Department of Aerospace Engineering and MySET, in which I am an associate member of it. So a big thanks to that for giving me that opportunity. All right, so a bit of my background would be that I am an alumni of Universiti Putra, Malaysia, where I did basically my PhD under the supervision of Professor Abdurrahim. So I started basically my PhD in 2012 until 2017. And before that, I did my bachelor in aeronautical engineering at the University of Glasgow. So basically, I am passionately towards the aerospace and aviation industry. Thereby, I would also like to nurture humanity through knowledge transfer, the sustainability, education, ethical values, societal engagement, as well as academic collaboration. So I have just been nominated as well a professional technologist about 2 months ago. And technically speaking, my research fields are aerogels, aero engines in terms of fire and thermal management system, as well as green insulation. So the green insulation doesn't really restricted into aerospace only. I'm quite interested about applying the concept of green insulation across industries. As far as the areas of interest is concerned, this one is like kind of in what I am interested in. So I am an advocate of sustainable aviation, aerospace management, as well as sustainability education. I had the opportunity to work at Management and Science University for the past 2 years. Thereby, I was in charge and I was teaching aviation management with piloting. And after that, I am now the managing director of the company that I founded 2 years ago. So for now, I am full-time in aeronautics. Okay, this is a bit of myself. Later on, perhaps at the end of the presentation, I will also provide what are the divisions of aeronautics group, as well as what do we do in this group. Okay, so for today, so we will be discussing about the aviation acoustic consideration. Okay, so that is the topic of today, and how is it related to environment and hence sustainability. As you would know that the main sources of environmental disruption at airports would be noise pollution and atmospheric pollution, thereby hence hampering the sustainability. I will come a little bit in a moment how do we define sustainability. I believe that most of you would know already by now what is sustainability, what is sustainable development, what is the SDG, the Sustainable Development Goals, and how our studies and how our everyday life is trying, how are we related to these 17 goals of SDG. So noise has an impact on physical and mental health, and also on the quality of life of every person affected. According to the Institut National de Recherche et de Sécurité in France, so noise can cause stress, sleep disruption, reduce cognitive performance, and cardiovascular disorders. That also I will bring a little bit how really the noise generated by, how is noise basically affecting a person's health. The consequences of noise environment at airports are inevitable. So noise is systematically cited as a major disruption to a day-to-day life. That is based on the studies that have been made, based on the feedback that have been received, the complaints. So the witnesses are complaining. They are complaining on an everyday basis. That is quite an issue. How should we how the aviation acoustic noise or acoustic performance should be evaluated and improved. Okay, a little bit of the aviation industry. I believe that most of our listeners today is within the aviation industry. So a little bit of facts and figures, but bear in mind that these facts has been last updated, let's say, by the end of 2019. As you would know that perhaps some of the figures would change because of the COVID-19 consequences, the repercussion to do that COVID-19. But as well, it is, I believe that I am quite optimistic about the industry. As you would know that by now there are around 1,400 airlines operating across the world, thereby flying over 25,000 commercial aircraft. So these airlines, the total number of commercial aircraft that they possess would be 25,000 commercial aircraft. In 2019, 4.5 billion of passengers were carried across the world. And Aerospace is managed by around 173 air navigation services and across 3,900 airports. This is quite a lot, considering that aviation is quite a recent industry, around 100 years plus compared to previous to other industries like automotive. The occupancy as well of that form of transport is 82%. 65 million of jobs are related to aviation and related tourism, and about 10 million of people is working directly in the industry, in the aviation industry. For the global economy, the aviation jobs is roughly 4.5 times higher than that contributed compared to other jobs. And if, let's say, aviation were to be a country, so then it would have been ranked 20th in the world based on its GDP that it is generating every year around 700 million USD. Okay, now coming to the sustainability as the title emphasizes. So the sustainable development requires the harmonization of environmental, social, and economic demands. These three, as you can see, are considered as the pillar of sustainable development. And wherever it is being merging, you can see that there is a performance due to the performance, the contributor, the two contributors. To compare of economy and environment, then you will be having sustainable economy. That is the common point where the two meets. So sustainability is about minimizing the adverse effects to the environment while maximizing the social and economic benefits. So this again, for the aviation industry, the economic benefits are greater than the transportation of goods and people. It doesn't restrict only to transporting goods and people. They include increased community job creation, as you could see in the previous slide, along with local business and tourism activity. The social benefit would be fostering international relations and social mobility. Although now we have social distancing, but well, hopefully soon we will be able to fly, inshallah soon. So then perhaps the social mobility performance will be increasing again. And the environmental stewardship includes the preservation of natural resources such as air, water, and land quality. So that is the point. Whenever we are developing new aircraft, we should consider the environmental contributor as well. As we would know that the economic and social benefit, it goes without saying, it is there. But whenever environment is concerned, then we need to advocate for it. We need to make sure that our technologies are not affecting the environment, I mean, at least minimizing the effects of the technologies. Yeah. So this is a bit of the basis of noise. Sound is a vibration that propagates as a mechanical wave. This is quite physics of pressure and displacement through a medium, and it is measured as decibels, dB. What is sound? A basic definition. So it is from dictionary.com. So noise is basically any unwanted sound. And noise pollution is an environmental stressor second to air pollution. It means that after air pollution, the second type of pollution that is most consequent is noise pollution. The figure beside over here could show you a bit of the range of decibels. Where are we on the safe side, and what are the decibels that are considered to be harmful? So above 85 dB, it is considered as harmful to us. So later on, we will see what is the measured sound that is being generated by aircraft approaching the airport. That will come a little bit later on. Okay, so what is the impact of noise on human? Although that maybe some of you, okay, most of you would be in engineering, but I guess that at the very least you did maybe you did biology at some way, yeah, around your education. So researchers has found that dying from a heart attack was more common among people increased in exposure to aircraft noise. This means that if a person is not sick, okay, so the chances of having a heart attack, if it is exposed to aircraft noise, it is higher. The probability is higher. So you have the acute effects, chronic effects, and long-term effects. The long-term effects, if you look into it, you could see permanent hearing loss and tinnitus. Tinnitus would mean that the person will be hearing a noise all the time. It's like a vibration inside the ears. And coming to the chronic effects, the hypertension is quite clear, reduced learning and productivity. This is what I meant earlier about cognitive performance. And endocrine disruption means the hormones are being disrupted. So your hormones are being disrupted. The acute effects is like short term, and you wouldn't get a very good sleep. You will be annoyed, and perhaps that your hearing ability would be also affected at some point, even on short term. So this diagram is giving about noise pollution, not necessarily due to aircraft, but this is the basis of the noise. What is the effect on human beings? Okay, coming on the real topic of the propulsion and the aircraft noise generation. So there are two primary sources of aviation noise that is aerodynamic and engine. The aerodynamic noise is the noise resulting from the flow of air over the fuselage of an airplane, and while the aircraft is taking off and it is landing, the noise is small. compared to when it is cruising. So why is that? Maybe you can think about putting while you're driving, you put your hand outside the car to the window, and you put it as perpendicular to your movement. That is, you put it as perpendicular to your movement, and then you will be seeing that the noise is higher rather than you put your hand horizontal to the same direction you're going. So like this, it will be much more noise. So that is how you can try to imagine. The aircraft would be making more noise because the airflow is almost perpendicular or 95 degrees. It is not in the same direction as the airflow. That is the basis. So from 0 degree to 90 degrees, the more that you increase the degrees, it will become even more noisy. That's why when cruising, it is less, the sound is less. Now, what about the engine noise? The engine noise is being generated because of two main reasons. The first one would be about the engine's combustion process, and the second one would be the sound of air passing through the engine. And you can see the picture over here that the different, these are the two distinct kinds, but in the picture it is quite distributed, and you can understand what are the noises that are being generated through an aero engine. The two most consequent one would be, maybe you can guess, so it would be the fan noise and the jet noise. So the inlet and the outlet. So these are the two noises that is more, it is louder. The noise is louder compared to the compressor noise and the turbine noise, which is inside of the engine. Okay, this is a bit of more detail of what I just spoke. So the two categories of noise from aircraft would be aerodynamic and engine. So coming to the aerodynamic, you can consider one is airframe and the second one would be flap. Even the flap is considered as part of airframe, but it is so consequent that we consider it to be another one, that this is divided under the aerodynamic noise. So we will not really go through the airframe noise for this time, but nevertheless, this is a bit of what you could understand from the slide. Coming to the engine noise, you would be having again, like I just mentioned, so the two main sources would be the fan and the jet. So in turbofan, aero engine noise is created by the interaction between flow, non-uniformities, and stator blades and rotating blades. So perhaps you can imagine from what you have followed in your previous class, where are the stator blades are located and the rotating blades. In modern high bypass ratio turbofans, the noise generated by the fan system has the main role than the one generated by turbine stages and the compressor. So comparing to turbofans, aero engine, and high bypass ratio turbofans. We will come into this later on in more detail. Perhaps you can get an idea of what I'm trying to explain over here. So that is regarding the fan. Coming to the jet noise, so it is due to the mixing of high velocity exhaust stream with the still air causes jet noise, which causes friction. Most of the engine noise comes from the exhaust or jet behind engine as it mixes with the air around it. So if you need to compare what is even more noisier, whether it is fan or jet, I leave it to you to guess whether it is fan or jet. Considering the actual technologies, yeah? Okay, propulsion noise. The engine has traditionally been the major source of noise, okay, due to what we have seen in the picture, and with other engine noise such as combustors, handling leads now becoming even more significant. Because why is it becoming more significant? Because the fan, turbine, and compressor turbomachinery noises, this has been researched and new technologies have been implemented. So maybe if one of you would be interested of doing research, so one of the gap you could see already is that the noises due to combustors and handling bleeds needs to be studied now compared to the other noises. So engine noise has significantly reduced as the bypass ratio of the engine has increased. So the higher the bypass ratio, the lower would be the noise. Okay, so it is inversely proportional. Acoustic liners in the nacelle are important in reducing the noise from engine internal sources as it propagates along out of the intake, bypass duct or core duct. So the sentence explains itself. The aircraft takeoff and climb performance has an important influence on departure noise since the thrust required and altitude gain greatly affects noise height on the ground. Okay. Okay, the progress. What has been the progress so far for noise reduction as far as aero engines are concerned? So the aviation industry has a long history of improving fuel efficiency. This is we know, biofuel and other sources of fuel, and safety, while simultaneously reducing noise. Okay, so this means that the noise, the research that has been done for improving fuel efficiency and safety has gone parallel for reducing noise. But is it the same? Is the pace the same? Is the improvement the same? That is yet to be looked into it later on. The aviation industry has achieved substantial and measurable reduction in noise over the 50 years through a mixture of airframe and engine technology and operational efforts. So you can see over here that the effort has been distributed for reducing noise due to airframe, reducing noise due to the engine, as well as operational efforts that is about the managing of aircraft around the airports. So the technology could be good, but if your pathway, if the pathway of the aircraft is very near to houses, so it is not 100, it is not efficient. So the operational effort as well is very important, and we will be seeing later on about the cases, the study case of what operational effort has been made. The industry has been working to reduce noise for decades, okay, 50 years already. Aero engine noise suppression has become one of the most important pieces of research due to airport regulations and aircraft noise certification requirements. So what is the motivation behind the reduction of noise? It is because of the airport regulation and the certification. So it is perhaps, maybe, we don't know whether the manufacturers are really interested in about reducing noise because by themselves, or because of being pushed by airport regulation and certification, which is done by ICAO. On average, aircraft have already 50, they are now 50% quieter than 10 years ago, and even 75% quieter than the first generation of jet aircraft. So this is quite a tremendous effort that has been made. Looking at the trend over here, so you would be seeing that from the 90s until 2015, you can see that the engines, the noise generated by engine has decreased. Okay, this is depicting, okay, what are the different models of engine and what are their noise performance. You would see also the chapter 3, chapter 4, and chapter 14. What it is the certification chapter from ICAO. So it is just a number that before it was in chapter 3, but now it is considered as chapter 14. The chapter 14 gives the updated regulation and the certification requirements. What are the certification requirements that the engine manufacturer should be taking into consideration, even researchers as well. So, okay, so historically, increasing the engine bypass ratio has delivered very significant reduction in aircraft noise. So if you would be asked what is the main technique that has been used to reduce aircraft noise, that would be increasing the bypass ratio. So however, increasing the bypass ratio further whilst delivering additional jet noise reduction would not deliver such significant reduction in aircraft noise due to other sources that comes from the fan noise. So even that you increase the engine bypass ratio, you have other sources of noise coming from the engine. One of it would be the fan noise. Such ultra high bypass ratio introduce additional design challenges, including the increased engine installation, drag and weight, the mechanical design of the fan, the aerodynamic performance of the fan, and the compressor and the low pressure turbine. Techniques for reducing jet noise without increasing bypass ratio involve promoting faster mixing of the jet exhaust with the atmosphere while minimizing the turbulence created in the mixing process. This sentence is telling us that, let's say that we cannot increase the bypass ratio anymore. Okay, we cannot. It is now constant. So how can we reduce the jet noise? Would be by mixing the jet exhaust with the atmosphere while minimizing the turbulence. So how can we achieve that? We will be seeing into this in a short moment. Such treatments bring with potential aerodynamic and mechanical design challenges, and there is a trade-off between noise benefits and potential fuel burn penalties. That is, there is a compromise between noise and fuel efficiency. Let's say you want to decrease the noise, then the fuel efficiency could be compromised due to that. Okay, this pictures looks quite nice, and you would be noticing that the engine has a different design at the back. So what is it? So it is called the nozzle lip treatments, such as the serration features in the flight testing. Okay, and it has been done under the Quiet Technology program, and also there is the Low Interior Noise Fan Nozzle Research program that has been done. So these are two different programs, two different researchers, and one is talking about the fan, and one is talking about for the jet noise. So you can see that the serration at the back, there has an effect on reducing the jet engine noise compared that it would be compared to before it's just rounded. So while having this serration, the jet noise is reduced consequently. We can look into this more detail into the technical aspect later on. This is just for you to have an idea, okay, about the new designs of engines. Okay, coming to the fan noise reduction with the reduction in jet noise. So fan noise is becoming the dominant source of aircraft noise, because we have the previous slide is about reducing the jet noise. So design features of the fan system for minimum noise include choice in the number of rotating blades and static vanes, the distance between these two rows of blades and vanes, detailed geometries of the rotor blades and stator vanes. Okay, these are vanes, and then stators. I'm sure that you followed the class of the Rahim, so you would be having a better idea of what is being written over here. So key issues are the fan aerodynamic and mechanical performance, stability and stall margin, and the manufacturing complexity and cost. Similar techniques are employed to reduce other turbo machinery noises, that is the turbine and compressor noise sources inside the engine. Okay? The overall system is optimized by harnessing the power of modern computers to model detailed aerodynamic flow over the blades and their mechanical vibration. So the picture here is depicting CFD, a computational fluid dynamics illustration while designing fan aircraft of engine. Okay, fan for the engine fan. So if you are interested about doing simulation and modeling for your masters or for further studies, and you are also interested in acoustic technologies, so that is one point for you to look into, because there is gap in about looking for solution to decrease the fan noise as well as the compressor and turbine noises. So reduction of fan noise radiation to the far field can be followed by four general concepts. It will be reducing the interaction mechanism between an optimal design of rotor blades and stator vanes, or to reduce the velocity deficit in the rotor weights with the flow of control techniques. It goes along, you can go through it, and you would see that these are the four general concepts that are being opted to reduce the fan noise. Okay, turbomachinery noise reduction. How can we reduce that? So acoustic liners. Acoustic liners, as you can see in the picture here, it is in front of the engine. It is in the nacelle, play a very important role in reducing turbomachinery noise before it escapes from the engine, as the acoustic energy is converted into small amounts of heat as the sound wave passes over the acoustic liners. So there is a transfer of energy here. The transfer of energy, so it is not as well efficient here. So simply extending the length of the nacelle to increase the area available for the acoustic liners introduces the weight and drag penalties, meaning that, let's say that you want to extend the nacelle, so then it is being compromised by weight and drag. So there is a need to increase the effective acoustic areas within the existing nacelle length. So the concept of extending the length of nacelle is not really good. And to enable acoustic liners to be applied variably in some more hostile areas of the engine, bringing significant manufacturing, materials, and design technology challenges. This means that if you want to solve one issue, there are other issues coming together. So you should be thinking very well before proposing one solution, because that could bring along many other problems or difficulties or challenges. So attention to detail is important, and the zero splice intake liner has been very effective in reducing the fan noise or aircraft departure far greater than one would expect for a relatively small increase in acoustic liner area. So you can see the improvement that has been made from A320, A340, and A380. So you could see that there are some splices around the nacelle, and they try to reduce the number of splices. And coming to the A380, there has been zero splice, no splice at all. So how has it been made? They have increased the acoustic liner area just by a little bit, but the improvement is quite effective. Okay, so it has been quite a lot of technologies. Let me try to resume of what we have been speaking and where are we really are. So this slide basically shows about the noise reduction technologies. What are the technologies that can be adopted to reduce noise in an engine? So you have basically 8 approaches. Some approaches have been well established, but some of them are still being researched by the industry as well as by the academia community. So the 8 of them would be the active noise control, acoustic boundary control, shape optimization, ultra high bypass ratio, duct flow, chevron, flow induced and unsteady blade forces, and finally acoustic liners. The reference for that is Technologies for Aircraft Noise Reduction. It is a review paper being published in 2020 this year. So please go through it, look for it, and you will be getting much more information about these technologies that are being employed. Okay. So reducing engine and entering noise has formed a key element of UK aerospace manufacturers' design criteria since the introduction of jet aircraft in early 1960s. As you could see in the previous trend, that the improvement. So 2 trends have been observed. The first one with significant step change reduction in noise associated with increase in engine bypass ratio. So this is one key approach that they have been opted is again increasing the bypass ratio. The second would be smaller reduction in noise associated with continuing improvement in noise reduction technologies and broader constant engine bypass ratio. These are some other minor reduction that has been done as time goes along. So it could be just some decibels that have been decreased per year, but if you count it from 1960s until now, so you can imagine if one dB is being decreased per year, it has already been a lot of years. But although that not every day we have new engines, but this is a way of speaking. So this is one aspect would be the bypass ratio, and one aspect would be about the other technologies. The evolutionary developments in airframe and engine noise reduction technologies have delivered typically 0.1 dB reduction in noise per year. Okay, this is the exact amount of how much of dB has been reduced per year, both on arrival and on departure, while theoretically revolutionary increases in engine bypass ratio have delivered step changes in noise. So both of it would be an overall reduction of 0.3 decibel per year. 0.1 decibel is being reduced because of operational effort that is managing around the airport and the airspace. And 0.2 decibel would be through engine technologies. Okay, so in summary, technologies has delivered major reduction in noise with aircraft, and now is entering service, demonstrating dramatic reduction in noise levels compared to those early jet ages. So aircraft now entering into service typically output half of the noise of the aircraft they are replacing. So let's say you have one model of aircraft, and then you have the new model of it. So you can consider that the noise is being reduced by half of it if you take up the new model. Further progresses, however, will require sustained investment in order to reduce the many different complex noise sources that contribute to the aircraft noise signature. So more effort is needed, and more effort is needed always. Comprehensive international noise research program have been launched involving industries, academia, research establishment, and universities, and many promoting concept of reducing noise are being developed. But further work is required to prove and to develop the ideas for application. That is the thing. Even though you are conducting research, but of course you need to make sure that it is as well being applied within a reasonable time frame. Without the support of government, definitely these has high-risk challenges wouldn't be able to be viable. Okay, so I would like to share a bit of over here a picture of what this is the locations. Previously, I mentioned about the technologies that can be employed to reduce noise. Now I'm showing the location of engines where the acoustic reduction can be considered. As you could see, one of it very right away, you could see the spiceless intake liner, which I just mentioned, we just showed on the A380. So that is one example. The other example that the other approach that is really being looked at nowadays is about the acoustic liners. As you could see here, I have encircled it, and this is trying to make it soundproof, kind of. So it is already spiceless, but we can still make it soundproof at some moment. So that is about the acoustic insulation. So you should be looking at materials that can be used to cover the nacelle, to cover these acoustic liners. But of course, the materials cannot be heavy, otherwise the weight of the engine will be heavier, and then the performance will be compromised. So you need to look for materials that are light but still delivering sound insulation. This is regarding acoustic liners, and as well as you can look at the other ones. Okay, so environment. This is related to sustainability now. We have already looking at technologies, the technical aspect. So let's see the sustainability aspect. So whenever any aircraft is being designed, you have, of course, combination of parameters that you need to look so that the aircraft efficiency is good. So regarding you have the performance that is related to safety, and as well as the performance, but you have also the environment attributes, which is noise and fuel. So these two are interrelated. They are interrelated. There are two emissions. You have fuel emissions and you have noise emissions. These two emissions, they are both attributed to the environment, of course. So whenever you want to decrease noise, like I mentioned before, maybe the fuel efficiency might be compromised. So it goes vice versa. Okay, it goes vice versa. So the local environment agenda for aviation is driven largely by noise and occasionally by local air quality impacts, whereas the national and international agenda is primarily focused on climate change and carbon dioxide emissions. So you can see that the international and national agenda as well, they are quite focused into climate change and carbon dioxide emission. What about noise emission? Not really, yeah? You cannot see it over here. So addressing these often competing demands is a constant challenge. Achieving an improvement in one area may come at the expense of another. Furthermore, noise solutions must be compatible with all other design requirements of both engine and aircraft. For example, the aircraft performance, the aircraft operating costs, the business needs, the manufacturer and the operator, the safe operation of the aircraft. So all these parameters, all these design parameters needs to be taken into consideration. So to best match the different requirements, the aircraft and engine manufacturer should be working closely so that we can come up to an optimum airframe and engine combination. Not all technologies are optimum on all aircraft, of course, because it is being compromised, and a total of system optimization has to be conducted. So you need to look the complete aircraft performance before while we are designing aircraft. Yeah. So this is a bit of the balance environment attribute. So this is what I just mentioned. For example, the engine parameters for the Airbus A380 were being influenced to meet the QC2 departure noise level. This is an operational demand. This is an operational demand at the London airports. So there has been a detriment to it, and this is regarding to the fuel burn and thus CO2 emissions. So if, let's say, they wanted the noise to be lower around the airport, so the aircraft somehow has burned more fuel, thereby emitting even more carbon dioxide. So this is another example will be about the large extension of cowling around an engine. It will definitely reduce the aircraft noise, but potentially lead to the increased aircraft weight and drag, resulting to a more fuel used in operation. So this is again an example of trying to contain the noise, but it is being compromised to the weight and drag, and hence the fuel efficiency. Another example would be the open rotor engine architecture, which offers significant potential for reduced fuel burn and CO2 emission. Although open rotor engines are likely to be quieter than today's turbofans, a trade-off between the fuel burn advantage and the noise reduction potential of fuel turbofan design. So there is again a compromise between these two. Now I would like to share a bit about the operational approach. We have so far discussed on the technologies and also the environmental attributes. So for now, I would like to go through a bit of certification that is associated with noise reduction for aircraft. So recognizing that aircraft aviation noise is a problem which needs to be addressed, the International Civil Aviation Organization has recommended for many years that national regulatory authorities adopt technical standards to limit noise from civil aircraft. One example, like we just looked before, would be about the chapters 3, chapter 4, chapter 14. So this is where you can find the requirements. The prime purpose of noise certification is to ensure that the latest available noise detection technology is incorporated into aircraft design, demonstrated by procedures which are relevant to day-to-day operation. To ensure that the noise reduction offered by technology is reflected in reduction around airports. So this is a push by the ICAO to ensure that the technologies are being implemented in the engine. To foster technology in development, ICAO regularly sets technology goals with the purpose of providing stretched yet reasonable targets for industry R&D to aim at in cooperation with countries. These ICAO technology goals are developed by panels and independent experts, which ensure transparency and involvement from all stakeholders, which means that the ICAO is here to put a certain, let's say, a nose level. So then the engine manufacturers or the aircraft manufacturers should be ensuring that they can meet these requirements. But of course, the ICAO will be bringing forward targets that can be achieved because it is being prepared by a panel of independent experts, as well as to ensure the transparency that, okay, let's say that one of the engine manufacturer already got the technology, maybe it will be taking just a very little time to reach this certification. So the transparency is important, and also the involvement of all stakeholders. Okay, this is a bit of zoom in into the different chapters of ICAO, the different chapters. So we are now at the chapter 14. Okay, and it is expected that the number of people affected by significant aircraft noise will be reduced, and the more that 1 million people could be removed from the day-night average sound level, DNL, of 55 decibels affected areas between 2020 and 2036. So this chapter 14 dictates the improvements of different engines. Okay, how do we quantify the aircraft noise? There are basically four types of noise metrics that are being used to monitor the noise level around the airport areas. So it could be the time-based noise metrics, the single event-based noise metrics, threshold-based metrics, and track-based measures. At least you would know, you're aware of that there are four types of metrics that can be opted to measure and quantify aircraft noise. It can be done by direct measurements with calibrated noise microphones or with high fidelity simulations. So if you have the proper input, you can simulate it, or you can do the actual test, or maybe you can do both to make sure that your simulation is calibrated, that your simulation is correct. Although that the four types of metrics are general methods that can be employed, the ICAO got their own measurement, and this is the reference. This picture shows the three references, the reference points that should be taken into consideration while the aircraft is being tested for noise performance. So you have the flyover, you have the sideline, and then you have the approach. So the aircraft acoustic certification involves measuring the noise level of an aircraft in effective perceived noise level (EPN) at three reference points, as it is being shown in the picture here. So if the aircraft manufacturer passes this test, it means that it can be certified. It will be certified by ICAO. All right. So now coming to the title again, gearing towards towards the sustainability, for quiet skies for sustainability, we need to find a framework. We need to look for a framework how we can ensure that this target of quieter skies is being achieved systematically. So for this, the ICAO has brought forward a framework whereby there are four approaches into it, and four let's say, 4 techniques that needs to be harmonized to make it a balanced approach. So the 4 approaches would be, the first one would be reduction of noise at source, that is the aircraft itself. The second would be the land use planning and management, so that people, basically, they are not having houses near the airport. That is about the planning, the land use planning. The third would be the noise abatement operational procedures. That is a job that is being done by the pilot. Perhaps, well, not only the pilot, but sometimes it is up to the pilot. It is completely up to the pilot to look uh, 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 for which way to approach the airport. Otherwise, perhaps the pathway is already being set by the people concerned, and then the pilot just follow the new route, so that to avoid crossing by near residential. And the fourth one would be operating restriction, that is, at a certain time, perhaps one of the model of aircraft is not allowed. If it is, let's say, at night, and this aircraft is so loud, it makes so loud noise, so it is not being allowed to operate or to approach the airport, or to depart from this airport, from this particular airport, because it is an old model of aircraft. So this is about operating restrictions. Coming to the first one, we have already been discussed. As you could see, this is about the first one is about the source of the noise, and this definitely we have already come across it from the airframe to the engine. But nevertheless, I have put over here maybe one picture that could illustrate to you what is the magnitude and the direction of the sound coming from an engine, aero engine. So you have different components. Okay, so you have the fan, the jet, the compressor, the turbine, and the combustor, but you can see the magnitude. Even the fan noise is not only in front; it is also at the middle, almost at the middle. So this is quite important. If let's say you are approaching an airport, or you are departing, it has an effect on it. It has a certain effects. Okay, the second one from the balance approach is about land use planning and management. Land use planning and management can be effective in ensuring that activities taking place near airport are compatible with aviation. The goal of this principle is to minimize the population affected by aircraft noise by means of zoning. That is, you have a certain zone. Different noise zones around the airport are defined to take account of aspects such as population density, increased airport traffic, or logistic activities. A good example would be the KLIA, as you would see that the KLIA has been shifted to Sepang. It is quite far from the residential area. So over there, it is quite an industrial zone, and it is a cargo zone, and there are quite less residents over there near the Sepang KLIA airport. Land use planning and management methods may be characterized as follows. There are three: the planning instrument, the action instrument, and then the financial instrument. So you have three subdivisions to ensure that the land use planning and management is being implemented properly. The planning instrument consists of ensure that planning is coherent, draw up legal definition of zones, consider relocation rights for landowners. Let's say they got already the land, so let's see whether there is any possibility for them to shift, to offer compensation. So this is the planning. The action is what needs to be done and what is doing. So building regulation, soundproofing programs, assignment of compatible users to purchase land, land management review, the grants, allocating grants to relocation and housing affected residents. The final one would be the financial instrument. That is, you have an investment into it. You provide tax incentive. You put airport. You set a certain airport fees. So that is to compensate. This is about the financial instrument coming from the land use planning and management. The third one would be from the balance approach is the noise abatement operational procedures. So these procedures aim to minimize noise pollution around airport by optimizing how aircraft use the facilities. The possibilities include noise preferential runways on routes and noise abatement procedures for takeoff and landing. So what is the preferred way? What is the preferred route? The appropriateness of any of these measures depends on the physical layout of the airport and its surroundings. So, for example, by extending the usable runway in the direction away from inhabited areas, aircraft can fly at higher altitude when they pass above nearby residential buildings. This technique is used at the Montreal Trudeau Airport in Canada. So they have extended the runway so that the aircraft doesn't need to be, the altitude doesn't need to be decreased as low as required before, because the runway has been extended. They can be at a higher altitude. Another technique is to require pilot to make U-turn once they have reached a safe altitude, thereby avoiding overflying certain zones. Let's say that the aircraft has already reached a certain altitude, so then the pilot is being instructed to have to take a certain route, to do a U-turn, to do a turn, not U-turn, sorry, so to do a turn at some point that to avoid residences. Lastly, a continuous descent approach procedure can be implemented. This technique enables crews to avoid the conventional step-down approach, which makes greater use of engine during descent. So noise and fuel consumption are both being reduced. So this is an example. These are examples of how noise can be reduced by operational procedures. Even your technology could be a bit not that state-of-art technologies, but yet you could opt for operational procedures to ease the difficulty of residences. The fifth one, the last one, is about operating restrictions. Restriction can be placed on aircraft operating at certain airports. There are 4 types of operating restriction. It has been here. Global restriction is applied to all traffic at an airport. Restrictions specific to certain types of aircraft, okay, because of their performance. Partial restrictions, which applied about the day timeline and the night time, what are the time that they can be operated. The progressive restriction, which entail gradually decreasing noise exposure over a period of time before reaching the target noise level. So this is a progressive restriction that is being implemented as time goes along. So some countries, especially industrialized countries, have considered banning certain noisy aircraft from the airport. This measure can have serious economic implications for airlines concerned, however. So if they have put a banning of certain aircraft, so you can imagine that this will have a repercussion on the airline. All these measures have been proven. Hence, the ICAO advises to start with the 3 principle, keeping operating restrictions as the last resort. So, operating restriction is because it is related to the economic development as well. So that is why it is taken as a last resort. Let's say that the airline is performing well, but its aircraft is quite old. So if you put a certain restriction, that has an economic implication of the jobs of the people working in the airlines. If the airline has to stop operating certain aircraft. Okay, this is a bit of a summary of the aircraft noise management, how aircraft noise could be managed. You can see about the sources. Okay, the sources are there. Climb out, cruise, approach, the different air noise, the ground noise, turn around, the engine testing, the taxiing. So this is related to the ground. And then below you have the mitigation. That is the approaches that can be taken into consideration to reduce noise. The number 1, 2, 3, and 5 comes from the balanced approach of ICAO. And the number 4 here, the number 4 is about communication and community engagement. So you try to even though, let's say, you have good technology, you need to ensure that the other 4 as well are being observed and are being taken into consideration, so that you have a synergetic effort, whereby the aircraft noise is being less annoyed by residents. I would like to share over here some example of implementation of the balanced approach. So we have 3 airports over here, and thereby, even it dates a little bit back, 2001, 1997. This shows that the ICAO has already been brought forward the initiative to reduce noise, aircraft noise. So we have a certain complaints. Let's say for the Brussels, we had 87 complaints. Liège had 27 complaints per year on average. Manchester in UK had 838 complaints per year. So you can imagine. So consider the Manchester airport. You can see that the implementation of the balanced approach has reduced the noise from aircraft, and the implementation rate is at around 50% for now. So it is a good progress. You can take it as reference, and you can have a better literature quoting these different airports on noise related to noise. So the source of this information is from 01dB. You can look online from 01dB. It is a company that is working for noise reduction for coming from aircraft. So you will be having lots of other examples of implementation of balanced approach. Okay, let's consider, before we trail towards the end of the presentation, I would like to share with you some case study. So one of the case study is about the use of noise modeling tools. If you remember, I just said some moments ago that simulation is one of the way as well to look into the noise effects around the airport. So Alaska Airlines partnered with Boeing and the Portland, Oregon from Oregon Air Traffic Control. They bring a more efficient and quieter airplane arrivals to the airport using performance-based navigation procedures. So they use the INM required for navigation performance precision arrival procedures were evaluated. It was evaluated, and what is the outcome of it? You can see from the picture from the left. That was the first step. Is the previous one. Over here is the before, and then that is the after. Right? You can look into the decibel here. How is it being decreased, or rather, it is the way back. Sorry, it is the way back. That one is the previous, and that one is the aftermath. This is after looking on using more efficient and quieter airplanes. That is the source of managing reported from managing the impacts of aviation noise. Please have a look at it. You can have a broader explanation coming from this case study. The second one would be the use of PDN. So this is about using satellite and trying to have a locally defined optimum descent. How the descent could be optimized, and hence trying to decrease the noise that is being heard by the resident. This is not about technology. This is just purely operational, using the simulation or using the satellite as well. So as you could see in the picture, in the middle picture, so you can see about the distribution of noise. And the second and the last picture, it comes up to be stopped quite here near the semicircle in the middle picture. So rather than going all the way forward and then coming back, they did a turn already by the middle. So what is the reason why they actually had to go all the way? So there's no reason for that. So that's why they try to optimize the route and make it less burden. But those staying very near the runway, this is no way for them to go, to escape that noise. Okay, let's say I'm pretty sure that you should be thinking about what happened while the airlines has stopped during the event of COVID-19. What happened? The skies became quite quiet and surely greener. So pretty sure. So that is, the nature was really happy about the aircraft stopping flying. But well, this is a report that has been done by the International Airport Review. So .com, please go ahead and look for it. You can see that some communities living close to the airport may currently experiencing a period of respite due to quieter skies. But one of the expected consequences when aviation activity levels increase is that noise will be more noticeable. So there will be more complaints, and there will be more complaints perhaps after the once aircraft are being resumed, because now the people will be say before it was quite no noise at all. So maybe there will be more complaints. Let's see what is the trend. So the UK Independent Commission on Civil Aviation Noise has called on the UK. Why UK? Because the engine manufacturers, it is taken into consideration by the rollers as well. So it's called on UK government to make managing aviation noise a key priority in a post-COVID-19 environment, when aviation levels begin to recover and start increase following the drastic decline in services as a result of the pandemic. So this could be because perhaps the airlines will try to catch up now with what loss they have done before. Maybe they will increase the frequency, so there might be more noises. So that's why they are taking into consideration already how the aircraft noise could be reduced. So there is also collaboration, and there will be also about using satellites and simulation to see how this can be resolved after the pandemic, what has happened. So a bit of the conclusion. This is quite brief, and still I would like to try to go for it. And so first of it is noise pollution is the second environmental stressor of the air pollution, and aircraft noise is regarded as a major nuisance in residential communities around airports. So you need to get the idea that the aircraft noise is really being noticed by residents staying near the airports. Of course, it has a certain effects on the performance, because it is also energy. Sound is also an energy. So if you have much sound, that means that you are dissipating energy. It is energy loss. So, but considering that it is not only technological, it is a nuisance for people staying around the airport. So if air transport industries are to meet the ever increasing demand of air travel, determined efforts are now required now to reduce the burden of noise upon these communities. Okay, so ICAO certification chapters dictate the noise pollution in aviation, and they have bring forward a balanced approach where we just look at the four aspects of it has been put forward by organizations to implement aviation noise reduction. Significant engine noise reduction have already been achieved in the latest generation of wide-bodied aircraft, and further reductions are being focused by the engine manufacturers, while academia and industry keep strengthening their synergic effort. So regardless of whether they are justifiable grounds for this optimism, there are alternative steps that needs to be taken, but the problem is basically an economic rather than a technological one. Perhaps this is a question, I leave it to you to think about it. How much does noise reduction cost, and how much can we afford to pay? Okay, so this one, I leave this session to a question that maybe can trigger to you. How can you debate on this, whether it is an economic or technological problem? Okay, so thank you so much for your attention. I couldn't follow really whether you have been asking how many participants has been there, but thank you for your time. And basically over here it is please feel free to be in touch, and definitely since Professor Abdul Rahim, he has been my mentor all the time. So if that acoustic has been interested to you and maybe you want to do research, perhaps we can collaborate and we look further how we can contribute towards reducing the aircraft noise. So that would be all, and I believe if you have any questions, please feel free to ask and let me know. Yeah, thank you.
Okay, thank you very much, Dr. Nadiir, for this very informative presentation. And just to let you know that currently there are 45 participants involved in this particular session. Of course, the numbers are increasing and sometimes it drop, probably due to internet connection. Okay, I open up to question and answer. So probably the participants can be students from the propulsion class or other guests that are already in this particular session. You may highlight your question, and you also can use the chat box. So I open up questions. Anyone? Maybe for a start, Nadiir, since you have highlighted many improvement, right, in the noise reduction, and of course, it's already more than 50 years in terms of the effort to try to reduce the noise. And research are still ongoing. Many works being done. If you look into in terms of the literature, there are still ongoing progress in trying to reduce the noise. Probably, in your own opinion, in terms of the global efforts, is it need some intervention from the government, or it totally rely on the aviation industry or the aerospace industry to resolve it, or what is your opinion on that?
Okay, so thank you for your question, Putra. So, first of it, we need to take into consideration that whenever we want to have an optimized result, perhaps there should be the collaborative effort. So, maybe in all directions, maybe a 360 degrees collaboration about with different stakeholders. We have the balanced approach as well, so what I have just been discussed, but definitely the effort that can be made by engine manufacturers or aircraft manufacturers, if let's say they have a certain approach that they want to opt, of course it will be taking years for the people to wait and for the aircraft to start operating and for the airlines to buy this particular aircraft for these people staying near the airport. So definitely, I believe that if we need to choose what are the approaches that can be taken in a short term, would be about approaching the land use planning, and this is where the government should become in the picture even more. Considering only on the fact that only on technology, because the technological effort are being made. It is currently being done and has always been done. But for the people to have a relief, the people would like to have a relief. So I would say that the government definitely needs to have a certain blueprint or a certain standard for developers. Perhaps let's say that we have a certain land development. So we need to look into this so that the residential area are not being created and developed near the airports. So it is a way forward for all stakeholders. It is a way forward for all stakeholders. But nowadays, with that event of the COVID-19, I'm pretty sure that the government should intervene even more nowadays. Yes.
Okay. Thank you for the response, Nadiir. Any other questions from the participants? You also have TS Ricky online. Thank you for joining, Ricky.
Yeah, thank you, TS Ricky. Feel free to ask question. Yeah.
We also have participants from all the way from Baghdad, Mr. Salman. Of course, the rest are students from Aerospace UPM, and some of them are quite family names. Right? Is there
perhaps we can have a feedback as well who are interested in about acoustic research. Maybe just pop in a message, raise your hand, and it's good to have feedback whether this session has been quite been interested for you. So maybe it would be good if anyone is interested about pursuing studies in acoustic research. So it would be good if you can raise your hand or just write a comment there so that we can get back to you and we can follow up. That would be good. Yes.
Okay.
Yeah, no, the question. Okay.
Any other question? If not, we can end our session very soon. But eventually, I've already promised to the aerospace students, the UPM aerospace students, there will be assignment related to this presentation.
Yes.
For those who are not here, probably they can view this session online in YouTube later on. So with that. Oh, there's a question there. From Yazan. Okay, Yazan all the way from Australia. Okay, question
Okay.
from Yazan. How can we solve the effect of engine aging? As you know, it causes the noise. Old engine probably. So, Nadir, any response?
Can you repeat the question? I couldn't follow the question from the chat.
Okay, the question from Yazan,
Yes.
he mentioned that how can we solve the effect of engine aging? So, old engine still
Okay.
in
Okay.
operation and it causes a lot of
Yes.
noise.
Okay. So how can we solve this problem? Okay. Um, Basically, if we want to improve an old engine, let's say we want to put a certain modification in an old engine, so definitely it will not be giving the same as one that has been having new technology. So at the very least, what we can do is taking into consideration some kind of insulation approaches. If that is the most straightforward, I believe, approaches that could be opted, because if you, let's say you have an old engine, you cannot change the bypass ratio. Even the bypass ratio would, if you increase it, the noise will be reduced, but you cannot change the bypass ratio of an old engine. So perhaps the most passive method, active method, would be changing quite drastically. So a passive method of to reduce noise from the engine would be the insulation of the engine, applying insulation. But of course, we need to take into consideration that even all engine is not that already efficient. So let's say if we are going to implement, if we are going to add on insulation to the aircraft, so to the engine, so definitely it will cause a weight and drag compromise. Maybe the engine will not be even more, maybe the efficiency will be even decreased. That is the expense. So if you have an old engine, you add passive insulation into it, the weight will increase, and then the engine will become even less efficient. So the best way would be definitely to opt new engines, that is new aircraft. That is one of the approach. But passive approach would be insulation.
Okay,
Yes,
thank you very
Thank you
much.
for your question.
Yes, thank you very much, Dr. Nadir, for the response. I
Yes.
believe we have to balance between the things that we want to improve as well as to get the right performance. At the same time, you have to think about
Yes.
the emissions, and there's so many things. It's not
Yeah.
just
So many
improve
things. Correct.
a quiet engine, but at the end of the day, you have to
Yes.
pay more on the fuel and so on.
Yeah.
So
Yeah.
probably this is the last question, and I would like to thank everyone. Oh, there's another question. Maybe this is the last one, right? I will read it out. Which one is more valuable, to improve the current engine or to try to design new engine? Of course, if you see there's a family of engines, right? It is been evolved, and then so many engines being developed from the same basic. Maybe I
Yes.
pass to Dr. Nadir to give his response on it.
Yes. That is correct, Dr. Rahim. So if we go to the maybe let me go to the slide that Dr. Rahim just quite many slides. Yeah. So that is correct. Comparing that. Okay, this is one slide that we can consider to reply to the question. So these are the technologies that can be opted to reduce sound, to reduce noise coming from an engine. But of course, perhaps not all of these technologies can be added on to all engines. Maybe while designing one of it, it could be possibly that the whole engines need to be changed. So we have different families of aircraft engine, but it would be much easier. Okay, this is the trend. Yeah, correct. So this is the for different engines. As you could see that it bears different names. It means that it is different engines. So to reply to your question, quite straightforward, it is easier to change the engine rather than to improve an old engine. Improving an old engine is not that, it is not an automotive or car engine that you can change, you put the turbo, you can easily modify it. It is not really like this because it goes through certification and other aspects of the aircraft is being considered as well. Yes, thank you.
Okay, thank you for the questions. Probably there are many other questions from the participants, but since we are running out of time, I also have to catch for another meeting. So on behalf of the Department of Aerospace Engineering, UPM, as well as the Malaysian Society for Engineering and Technology, we would like to thank Dr. Nadiir Bheekhun for his informative presentation, and also thank you to all participants that are involved in this particular session, and you may also view this particular recording in YouTube. I will post it to the group later on, and with that we are going to have our next seminar on the 18th of July. There will be a talk from just a teaser to you, to all of you. There will be a talk by a speaker from the Sepang Aircraft Engineering on quality. So stay tuned. We will have more on this webinar web series. Brought you by UPM as well as MySET. With that, thank you very much and have a good day. Assalamualaikum warahmatullahi taala wabarakatuh.